You know when you look at a painting and just wish you could see the world through that artist's eyes for a moment? Well, what if a computer could do just that? I'm not talking about copying a painting, but actually understanding its style and applying it to any photo you want. We're about to dig into a truly groundbreaking paper from 2015 that made this a reality. And in the process, it revealed something pretty profound about how we all perceive art. Okay, just look at this. On the left, you've got a perfectly nice photograph of a town in Germany. But on the right, wow, that is the exact same scene, but it's been completely reborn in the swirling, incredible style of Van Gogh's The Starry Night. Now, this isn't just some clever photo filter. This is an algorithm that has learned the essence of a masterpiece and painted a whole new image with it. So the question is, how on earth is that even possible? Right, so how can a computer, which is all about logic and code, learn something as human and, subjective as artistic style? To get that, we first have to understand how a computer learns to see anything at all. The tool behind this whole magic trick is a really powerful type of AI that's actually inspired by our own brains. It's called a convolutional neural network, or a CNN for short. Now, these things are the absolute superstars of image recognition. A CNN is what lets your phone find all the pictures of your cat, or helps a self-driving car tell the difference between a stop sign and a tree.
Think of how a CNN looks at an image like we build something with Legos. The very first layers, they only see the most basic bricks, simple edges, little patches of color, basic textures. Then the next layers start combining those bricks into slightly more complex shapes, like a window or a roof line. And finally, the top layers assemble all those shapes to understand the big picture stuff. Okay, that's a building. There's a river. That's the sky. It builds a complete picture, layer by layer, from the simplest little details to the most complex objects. And it was deep inside this layered structure that the researchers had their big eureka moment. They realized that in the process of learning to recognize things, the network had accidentally taught itself something incredible: how to separate the content of an image, what it's a picture of, from its style, how it actually looks. This is the absolute core of the entire paper. The what, which is the content, and the how, the style, are represented in totally different ways inside the network. They're not all tangled up. You can actually pull them apart. So what does that actually look like? Well, check this out. The researchers asked the network to remake the photo using only its highest layers, the ones that understand the big objects, and this is what they got. You see how all the fine details, the specific colors and textures are just gone? But the overall layout of the buildings is still perfectly there. This is the pure content of the image. Now, let's flip it. Instead of the high-level objects, the researchers looked at the textures and patterns found across all the layers, things like which colors are usually next to each other, or what kinds of brushstrokes are being used. When they rebuilt the image from that information, the scene itself basically disappears. But what's left is the unmistakable texture, the color palette, the raw energy of the painting. This is its pure style. So once you figure out how to isolate content and style, well, the next logical step is to start mixing and matching to create something totally new. And the recipe for this is actually pretty elegant. The algorithm takes a photograph and pulls out its content. Then it takes a famous painting and pulls out its style. And finally, it generates a brand new image from a blank slate that matches both the content of the photo and the style of the painting. The results are, honestly, just stunning. Let's look at a few more. First up, here's our photo of Tübingen, but this time it's reimagined with the dramatic, hazy light of J.M.W. Turner. I mean, look at how the algorithm totally nails that atmospheric glow. All right, next, watch what happens when we apply the swirling, emotional intensity of Edvard Munch's The Scream. The whole mood of the scene just transforms. That calm little river now feels anxious and tense, all because of those iconic colors and frantic brushstrokes. And here it is, reimagined through the fractured, geometric lens of an early Picasso. The algorithm literally deconstructs the scene into these different planes and angles. It perfectly captures that feeling of cubism. And for a final one, look at this, the vibrant, chaotic energy of Vasily Kandinsky. The original photograph is almost completely gone, dissolved into pure color and form. It's just so clear that the algorithm can handle this incredible range of styles, from total realism to complete abstraction. And what's really cool is that this isn't just an on or off switch. The researchers found they could actually control the balance.
You can tell the algorithm, hey, focus more on the content, and it'll look more like the photo, or you can say, no, really lean into the style, and you'll get something much more abstract and painterly. It's a sliding scale you can play with.
So yeah, this is an amazing way to make beautiful images, for sure. But the implications of this research go way, way deeper than just that. This was never just about teaching a computer to be an artist. It was about using that process to learn something fundamental about perception itself. The really crucial takeaway here is that this paper gave scientists the first ever algorithmic model for a deeply human process. It opened up this fascinating possibility that our own brains might work in a similar way, that as you and I look at the world, our neurons are constantly separating the content of what we see from its appearance. For neuroscientists, this wasn't just a cool idea. It was a concrete, testable model of human perception. And that all leads to this really profound conclusion from the paper itself. Maybe our ability to create and enjoy art isn't some, mystical separate skill. Maybe it's just a direct side effect of having a really advanced visual system that just to understand the world has to first learn how to separate the what from the how. This paper from 2015 didn't just create a new tool. It basically kicked off the entire AI art revolution we're living in right now. And it leaves us with this huge question to think about. If an algorithm can learn the very essence of artistic style, what does that tell us about the nature of human creativity itself? That's a question that art, science, and technology are all still trying to figure out.